Hello class. In this video, we review for test 2. Let's go to my lab math. Test 2 covers chapter 8 and 9. There are 33 questions in the review. What I remembered is there are about 15 questions in the actual test. Let's get started. Question number 1. Suppose that the local sales tax rate is 4% and you purchase a car for $29,700. Part A. How much tax is paid? Tax amount. The amount of tax is a part of the sales price value-wise. So based on the formula, part equals percent times whole. We have the amount of tax equal to tax rate multiplied by the price of the car. So let me get a calculator. %4 as decimal is 0.04. 4% multiplied by the sales price of the car multiplied by 29,700. And the multiplication is $1,188, 1188. That's the tax, sales tax. Part B, the total cost of purchasing the car. Not only you have to pay the dealer, you also have to pay the government. So we are going to add the tax amount to the price of the car and to have the total cost of the purchasing the car. So we're going to have, this is the tax, right? We're going to add that on top of $29,700. The sum is $30,888, 30888. That's the first question. Question number 2. An exercise machine with an original price $940 is on sale at 9% off. So this is about discount. 2 parts. Part A, what's the discount amount? Discount amount is also a part of the price. So same formula, part equals percent times whole. You remember the formula or the chart I gave you in the table note, right? The 3 things, percent, part, whole. If we know 2 of them, then we are able to find the value for the third variable. In this case, we are missing part, discount amount, which equal to the percent times the whole. So we are going to use the discount rate, 9%. 9% as decimal is 0.09. Oops, let me restart it. So 9%, 0.09, multiplied by the original price, 940. And the product is $84.60, 84.6. 85.6. And that's the discount amount. Sales price. Since this situation, the situation of discount is marked down. Earlier, question 1 is marked up, right? This is marked down. So we are going to subtract the discount amount from the original price to have the sales price. So we are going to use the original price, 940 minus the discount amount, 84.6. The difference is $855.40. 855.4. 855.4. Okay, and those two amounts add up. If you add up those two amounts, you should have the original price. And that seems right. That's the second question. Question number 3. The bar graph shows that life expectancy, the number of years newborns are expected to live in a particular region, has increased dramatically since ancient times. Find the percent increase in average life expectancy of the region from the Stone Age to 2016. So we're looking for increase, a percent increase. Let me get my OneNote. I need to do some calculation here. Remember in my video, I emphasize whenever you need to find the value for percent increase or percent decrease, the first thing you need to do is to write down original value and a new value. So here we are considering from Stone Age to 2016, right? So as you can see, the life expectancy for Stone Age is 23. So I'm going to write original. You're going to do the same thing on your scratch paper. Original, what is it? 23. And the new is increasing, so from original to the new 2016. The new value is 65, 23, 65. Okay, so and then second step, you write down the formula for percent increase. I have those in both my table note and my video. Percent increase equals new value minus original value all over original value, right? New value 65, original value 23, all over original value 23. You have those values written down on your scratch paper. So all you need to do once you have the formula ready, just plugging in. Numerator 65 minus 23, 42. Denominator 23. And now we are going to do the calculation. Use the calculator. Divide 42 by 23. And we got a decimal, right? Yeah, let's see how do we round the decimal. It is so important to pay attention to the sentence in the parentheses. If you want to pass or have a good grade for test 2, please read the information in the parentheses. What kind of rounding rule you need to follow? In this case, round it to the nearest integer as needed. So we are looking for a percent, right? The percent we got is, so if we round it to 1.826, 1.826. So if we round the decimal to 1.826, round it down, next digit is 0, round it down. Then convert this decimal to percent, move the decimal point to the right 2 places, and then attach the percent sign. We have 182.6%, right? But the question asks us to round it to the nearest integer. So we're going to round it up to 183%. You see how do we handle the rounding right here? Not just you need to know what is original and what is new, what is the formula to compute the percent increase. You have to take good care of the rounding part, the last part. So the answer that we're going to enter is going to be 183. Okay, please do not enter the decimal you got. I know you got a decimal in the calculator, but the problem already have a percent sign right behind the cell. You need to enter the integer in front of the percent sign, the percent point. Okay, yeah, let me double check. So 100 round to the nearest integer is needed. That's correct, 183%. Next, a sofa regularly sells for $740. The sale price is $673.40. Find the percent decrease. Okay. Find the percent decrease of the sofa price from the regular price. So let's do the same thing. Write down the original and the new. So this is a decreasing change, right? So original price is $740, and the new price after discount is 673.4. 673.4. Yeah, write it down. You should be more convenient because you're gonna have a paper scratch, a paper on for your convenience. I have to go back and forth to make sure that I'm not copying anything wrong. 740, 673.4. Okay, and percent decrease formula. The test is a closed book, closed note, so you need to memorize those formulas. And those formulas, to be honest, are not difficult to memorize once you understand them. Focus on understanding them. Percent decrease, numerator, original, sorry, is different, so it's decreasing. So original minus new. The numerator always is a bigger quantity minus the smaller quantity. The denominator always original. Okay. Original is 740. The new value is 673.4. And original is 740. Okay. Just plugging in. Let's process in a calculator. Numerator 740 minus 673.4, and that's, oh yeah, that's correct, 740 minus 673.4, and that's the numerator. Divide that numerator by 740, and the decimal we got is 0.09. And let's look at the instruction here. It doesn't have any instruction, right? Because we have a finite decimal, 0.09. Convert 0.09 to its equivalent percent, we have a 9%. So please do not enter 0.09 in the cell because the percent sign is already attached. So all you need to do is just enter 9%. Make sure you understand what I'm talking about here. Question number 5. At the time of her grandson's birth, a grandmother deposits $8,000 in an account that pays 8% compounded monthly. What will be the value of the account at the child's 21st birthday, assuming that no other deposits or withdrawals are made during this period? And you can use the formula for sure. And you're going to know which formula to select, right? I'm going to use my TVM, time value of money solver. Give me 1 second. Let me get my calculator set up. And let me firstly take the information of the question. This is about compound interest. Compound interest. By the way, no problem. You use the formula. I'm just if I go to take the test, the method I'm going to apply, I would use the solver because it's easier. So I got the information written down, and I'm going to share my calculator. Okay, so turn on my calculator. I'm going to, this actually already in the app, okay, already in the app. So let me share the camera one more time. Give me a couple of minutes. Let me get it settled. I'm trying to share my calculator, but the system seems not letting me. Try more times. Hello. Finally, I could share the calculator. Sorry about that. It took me a while. I hope this will not change. It was sharing just a little bit and then disappeared. So, okay, let me make sure I'm not muting myself and it's sharing and it's recording. Okay, so let's go to the apps, finance, PBM solver, and you should be very familiar with this manual here. We are handling a compound interest problem, right? So let's see, the interest is compounded what? Pays 8% compounded monthly. Okay, monthly. So we have 12 times for how many years? from the birth of the grandson to 21st birthday, so 21st years, right? 21 years, so 12 times 21. 12 times 21. Let me turn on the light. I can't really see the. I have the light turned on. So the big N is 12 times 21. Let me do it again, double check. 12 times 21. So 252. And the annual interest rate is given. Annual interest rate is 8%. So we leave 8 here. Present value is original principal, right? The grandma deposits 8,000, so 8,000 right here. And payment, since during the 21 years, no deposit, no new deposit, no withdrawal, so payment is 0. And future value is what we're trying to solve for. P per Y and C per Y, keep them as 12 because the interest is compounded monthly. And we go back future value, we are going to solve for future value. So in the future, the 8,000 will become $42,685, around 80 cents, right? So now let's go back the test, the review. Right here, okay. So the value of the account will be, reading information, please. Round to the nearest dollar as needed. Round to the nearest dollar as needed. So we are going to round it to the nearest dollar, round it up. We're going to have 42,686, right? Because the 10th, we have 7, so round it up. 42686. And also allow me just a little bit of time. Let me quickly double check by using the formula. 8,000 multiplied by 1 plus 8%, 0.08 divided by 12, close the monthly interest rate, close the compounding factor, and then raised to the power of 12 times 21 years. 42686. Yeah, we got the same result. Very good. I'm sure this is correct. Round to the nearest dollar as needed. Next. And let me double check I'm sharing. I'm not muting. I'm not muting. I am sharing and I am recording. Okay, very good. Question number 6. How much money should be deposited today in an account that earns 7% compounded semi-annually, such that it will accumulate to 9,000 in 3 years? In this case, this is also a compound interest problem, but the future value is given. A, accumulated balance A is given. Original principal is unknown. So which formula should we apply? We should choose the second one, right? Yeah, if you want to use the formula, and that's the formula we need to use. And you know, I would like to use my calculator to show you. My purpose is to make your job easier, okay? Even actually when I'm making the video, sharing back and forth is not very convenient, but I just want to show you this method is superior. And let's go back the apps finance TDM solver. Okay, let me look at the information of the problem. Take a quick picture of the problem. So semi-annually for how many years? 3 years. Let's go back to the calculator. Semi-annually, right? So 2 times 3, 6 times. The interest is going to be compounded 6 times because twice a year for 3 years, that is going to be 6. Annual interest rate 7%. Present value, we don't know. That's something we need to solve for. PMT payment is 0. Future value is given. Future value, you want a 9,000 in 3 years. So enter 9,000. Very important. P per Y, C per Y. Since the interest is not compounded monthly, instead, interest is compounded semi-annually. So you want to keep 2 here, okay? Here's 2, P per Y is 2, C per Y is also 2. And then we go back, PV, present value, the original principal. How much you need to deposit today in order to guarantee 9,000 in 3 years. And we solve for that value. $7,321. Okay, let's share back. I know this is not very convenient. I just want you to, to know the best method or the method that could make your test easier. Waiting for the tunnel. Okay. Okay, so how do we round it? Round up to the nearest cent. Round up to the nearest cent. We need to guarantee, we want to guarantee $9,000 financial goal in 3 years. So we must round up the principal today. Round up to. You need to make sure you see the difference between round to and round up to. So the decimal we got is $7,321.50. 505,799. Yeah, on your calculator you should have the same thing. And we are going to round up to the nearest cent, and the answer is going to be 7,321.51. Always round it up. It doesn't matter what's the digit in the thousandth place. Even is less than 5, you still have to round it up. Okay. Before we submit, let me use the formula to double check one more time. So 9,000 divided by, denominator is going to be 1 plus parentheses 0.07 divided by 2. Close the annual interest rate, close the compounding factor, and to the power of twice a year for 3 years, 6. 7321.51. Same thing. That's correct. Number 6. How much money? Oh no. So we are looking for number 7. Number 7. 2 parts. Use the appropriate formula to find the value of the annuity. Okay, so this is about annuity. Annuity formula is so complicated. I really just hope you know the TVM solver method. And same thing, I'm going to write down those information. What do we have about this annuity? Periodic deposit is 1,500 at the end of every 3 months. So this is quarterly, right? Every 3 months. Rate is 6.25%. I need to constantly check everything's fine now. Okay. Compounded quarterly. Time is 5 years. That's the information we are given. Part A. What's the value of the annuity? Value of the annuity is the future value, right? Remember, the present value of annuity always equals 0. Do not round until the final answer, then round to the nearest dollar as needed. Okay, you ready for my calculator? Share camera, HD camera, share camera. Okay, I'm still unmute. Let's go to the app, Finance, TVM Solver. Okay, let me look at the information that I just had. Capital N, so quarterly 4 times a year. For how many years? 5 years, right? Quarterly 4 times a year for 5 years. 4 times 5 is 20. Annual interest rate 6.25. 6.25. Present value 0. Annuity. Present value of annuity is always 0 because we are talking about ordinary annuity. In the beginning of your account, you have nothing there, $0 until the first payment you make. And payment, let's see how much you deposit, how much you contribute every quarter. You contribute $1,500, so it's a negative $1,500. Oops, let me redo it. So negative $1,500 because the money going out, right? So you can put a negative sign there to indicate that. Future value is we are going to solve for. So skip it, and we are going to go back very quickly, shortly. P per Y, C per Y, since it's quarterly, we're going to have 4 there, all right? And we go back future value and solve for that. Let me double check. 4 times a year for 5 years, 20. 6.25. Present value is 0. Payment is negative $1,500. P per Y, C per Y is 4. Yeah, that's correct. That's going to be our answer, all right? $34,899.77. Let's go back our test. Waiting for the tunnel. And let's read the instruction here. Round to the nearest dollar, so not cents. You see the difference? Yeah, we need to be very careful. Round to the nearest dollar. So in 5 years, your annuity, the value of your annuity is going to be 34899, but we're going to round it up. That's going to be 900. 34,900. $34,900 if we round it up to the nearest dollar. And second part, the interest. How do we find the interest? Let's calculate on a simple calculator. So you deposit, how much you deposit? You deposit $1,500 every quarter, right? For how many years? For 5 years. So multiplied by 20. That's how much money you contribute to the account, annuity. But you in 5 years you will harvest $34,900, right? And the difference will be the interest. So we are going to minus 34,900, and the difference is going to be $4,900. $4,900. Does that make sense? The difference between your gain in your the future value of your annuity and the money you contribute over the 5 years, the difference between those two amounts is your interest, is your gain from the annuity. Use the answer from part A to find this answer. Round to the nearest dollar as needed. And that's correct. So that's about annuity. Number 8. To offer scholarships to children of employees, a company invests $12,000 at the end of every 3 months in an annuity that pays 11% compounded quarterly. 2 parts. A. how much will the company have in scholarship funds at the end of 10 years? So part A, we are looking for the value of the annuity in 10 years. Part B, find the interest. Same with earlier, right? Just different values. Let me get the information. The information about the annuity is interest rate is 11%, pretty high. So the not monthly, quarterly contribution is 12,000. That's a lot. And for how many years? 10 years. Okay. So we got the information, and we are going to go to my calculator. Share camera. Okay. So this is already in the time value solver, right? Let's go up. If you don't like the previous data there, you can just clear everything and then start over. I don't see the necessity doing that. So it's quarterly for 10 years, so 40. Okay, 4 times a year for 10 years, of course 40. Annual interest rate 11%, 11 here. Present value of annuity always 0. Payment, quarterly payment, negative 12,000. That's a lot. Negative 12, 1, 2, 3. And the future values we are going to solve for. And P per Y, C per Y, P per 4, because this question is also about quarterly. Depends on your question. You're going to read the question very carefully. If it's annually, you leave 1 there. If it's semi-annually, you leave 2 there. Quarterly, you leave 4. If it's monthly, you're going to have 12 over there. And we go back to solve for the future value. Let me double check. 4 times a year for 10 years, 40, 11%. Payment negative 12,000 at the end of every quarter. Okay, that's correct. So the answer we got is 800. That's a lot. 855,000 to like 0.8 million. $855,217. 74 cents. Okay, let's go back our test. Waiting for the tunnel. Let's see how do we round the answer. Do not round until the answer, then round it to the nearest dollar as needed. Okay. So we're gonna enter 855, 218, 218. Since the tens is 7, it is okay. I'm not entering actually. Let's do it again. 855, 218. Double check to the nearest dollar. $855, $855,218. Okay. Part B, interest. Okay, interest. We had a similar problem earlier, right? So in this case, you deposit, the company deposit 12,000 every quarter for 10 years. Every quarter for 10 years. So multiply by 40. That's the total contribution to the account, right? But in 10 years, you have more than that. Yeah. How much you have after that? After 10 years, you have 855,218. So we're gonna minus 855,218. You see, I'm not rushing. I take my time because if I mess up just a little bit, I will not get the right answer. And the difference is 375,218. 375. Just ignore the negative sign. 375,218. Double check. Usually, your device would be more convenient with scratch paper and handheld calculator since you don't have to demonstrate or sharing. And $375,218. Okay, ignore the negative sign. Use the answer from part A, round to the nearest dollar. That's correct. Question number 9. Use the appropriate formula to determine. You don't have to follow the method that the question asks you. It doesn't matter as long as you give the correct answer. So this is also about annuity. But this time we are not looking for the value of the annuity. Instead, we know our financial goal in the future. We want to know how much we contribute periodically to guarantee to achieve that financial goal, right? So let's read the information. Rate is 4.5% compounded quarterly. So far, everything is quarterly, but doesn't mean when you take the test, it's going to be quarterly. So you have to read the question. For 6 years, in 6 years, you want to have 30 grand. So how much you need to deposit every 3 months? So that's the question. So this time we are going to find the monthly payment, okay? Find the monthly payment. Use the to determine periodic deposit. Part B, how much of the financial goal comes from deposits and how much from the interest. If you spend time and effort doing your homework, those questions are not strange or unfamiliar to you. You should have seen those questions many times because they are from the same pool. Let me share my calculator. It's gonna be a little bit slow because I have to share back and forth. So look, let's go back. This is also quarterly, right? Quarterly for 6 years. So 4 times 6, 24. Annual interest rate 4.5. And present value always 0 for annuity. Payment, we don't know. That's something we're going to solve for. Future value, 30 grand. 1, 2, 3, 4. Quarterly 4, quarterly 4. So let's go back. Payment. It doesn't take 10 seconds, right? Yeah, double check. 4 times 6, 24. 4.5, 0, 30 grand, 4, 4. Okay, so that's the answer. You need to contribute like $1,095, $96 actually, rounded up, to guarantee that financial goal. Let's go back our test. Waiting for the tunnel. Read it here. Do not run until the answer, then round up to the nearest dollar. Round up to the nearest dollar. I cannot emphasize that even more. If you want to pass test 2, you need to listen what I said. 1096. Okay, round up to the nearest dollar. 1096. And how many of those dollars from deposits? Then let's figure that out. You deposited 1096 every quarter, right? For 6 years, so times 24, and that's how much you deposit. So that much money comes from deposits. 26304. 26304. And how much from the interest? Then we just use the financial goal to minus the deposit, right? And minus 30 grand. 1, 2, 3, 4. And difference is the interest. 3696. 3696. Use the answer from part A to find these answers. Round to the nearest dollars as needed. And make sure those two values, they do add up to 30 grand. Did I make any mistakes? Nope. That's correct. Next. Question number 10. Suppose that you borrow 15,000 for 4 years. And let me double check everything's fine. Not muted. I'm recording and I'm sharing as well. Okay. Number 10. Suppose you borrow 15,000 for 4 years at 6% toward the purchase of a car. So this is about a car loan. To find the monthly payments and the total interest for the loan. Okay. I'm not using the formula, too complicated, consuming my time. So I'm using the TBM solver, okay? So that's the loan amount, 15 grand. 4 years, 6%. So those are the information about the car loan. Monthly payment, we need to find the monthly payment first. Okay, so let's go to the calculator. TBM solver, we are here already. So how many years the loan? I remember it's 4 years, right? 4-year loan. So 12, since you are depositing monthly payment, 12 times 4, you are going to deposit 48 payment during the longevity of the loan, 48. Annual interest rate is given, it is 6%. And present value, this is not annuity, okay? This is installment loan. So the present value is your loan amount, 15 grand. And monthly payment is we are trying to solve for, so skip that. Future value of the loan always be 0. You don't want to owe anything in 4 years, so you want to pay off the loan in 4 years. So future value is 0. And for car loan or mortgage, yeah, it's always monthly, but it's better also read the question, just make sure. So 12. And let's go back to payment to solve for the payment, monthly payment. Let me double check. 4 years, so 48, interest rate 6%, loan amount 15 grand. And those entries need to make sure nothing wrong with it. So your monthly payment is $352.28. Go back to our test. Our test here. Yeah, monthly payment. Read the instruction. Do not run until final answer. Round 2. It doesn't say round up to, okay? Round 2, the nearest cent as needed, okay? Not dollar anymore. Round to the nearest cent, so $352.28. The reason we round it up is because the next digit is 5, so we round it up. 352.28. That's the first part. Second part, part B, total interest for the loan. How do we figure out the total interest for the loan? So you deposit 352.28 every month, right? Over 4 years, So multiply by 48. And that's how much money you give the dealer. You give the dealer. But you actually only owe how much? You only owe 15,000. Then the difference would be the interest, the cost of the loan. 1909.44. 1909.44. Double check. Use the answer from part A, rounded to the nearest cent. 1909.44. That's correct. Next. Suppose you decide to buy a car. This is about a car again. including taxes and license fees. You saved $9,000 for a down payment and can get a 5-year car loan at 6.77%. Find the monthly payment and the total interest for the loan. And what's the difference of this question? You need to be careful when you're funding the loan amount. Okay, the price of the car is $27,635, but you are not going to borrow that amount of money because you have some savings, right? All right, your loan amount should be the price of the car minus 9,000 because you have down payment. Let's go to my calculator. Where's my calculator? Okay, right here. About the car loan again. How many years the loan? You got a 5-year loan. 5-year loan. So 60, right? 12 times 5, 60. Annual interest rate 6.77. Be careful when you enter those values. Make sure you do not accidentally enter wrong number. 6.77. I always double check. Your loan amount, again, your loan amount is not the price. The price is 27,635. Your loan amount is not that amount. It's to minus your down payment. Your down payment is 9,000. 1, 2, 3. So that's the loan amount. Yeah, the difference, the money you are 18,635. Yeah, the money, that's the money you need to borrow. You don't have that money. You have 9,000 only. Okay, monthly payment is we're trying to solve for. Future value is 0, 12, 12. Okay, everything looks fine. And payment, solve for payment. Your monthly payment is supposed to be $366.98. Yeah, before we go back, let me double check. 5-year loan, so 60, 6.77. And price minus 9,000. 27 minus 9 is 18,635. Yeah, everything's fine. Let's go back. The test. What do you need to do? Read rounding rule. Round to the nearest cent as needed. Okay, we round to the nearest cent as needed. 366.98. Because 97652, 6 is bigger than 5, so round it up 98. 366.98. Total interest for the loan. We had a similar thing, right? Total interest. So you pay $366.98 over 5 years every month, right? So multiply by 60. Multiply by 60. That's how much money you give the dealer. You give it to the dealer. And you owe the dealer. Oh, I have to figure out how much you owe the dealer. You owe the dealer 18,635. 18,635. 18. Yeah, you're gonna have that amount on your scratch paper. 18,635. Or it's actually on your app. In your app. That's how much you owe. Please do not subtract the car price. You do not owe the price, the whole price. You owe $18,635. And the difference is the cost of the loan. 3383.8. 3383.8. 3383.8. Round to the nearest cent as needed. I believe this is good enough. Or just put a 0. It's gonna be the same. $3,383.8. Next. Question number 12. We have many parts in this question. This is about housing. And this is about purchase a house. We need to determine the regular payment amount rounded to the nearest dollar. The price of a home is $235,000. Bank requires 20% down payment, 3 points at the time of closing. Cost of the home is financed with 30-year fixed rate mortgage at 10%. Complete Part A through Part E. That's a big project. Okay, getting information ready. Find the down payment, all right? So how do we find the down payment? 20%, 0.2. Multiplied by the price of the house. What's the price of the house? $235,000. 23. And down payment is 47,000. Double check. 20%. 235,000. 47,000. 47,000. Okay, that's part A. It's pretty straightforward. Part B, find the amount of the mortgage. Is how much money you need to borrow. Okay, so you can either subtract 47,000 from the price, or something I like to do is to multiply 0.8, because you pay 20%, you have to borrow 80% by the price, 235,000. 188,000. 188. And make sure those two values should add up the price of the house. 188 plus 47, that is 235. Exactly, yeah. Part C, how much must be paid for the 3 points at the closing? 1 point is 1% of the mortgage. 3 points would be 3% of the mortgage. Did we just have the mortgage in Part B? 188,000, that's the mortgage, right? Just multiply that by 0.03. I messed up. Try again. 0.03, 3%. 5640. 5640. 5640. 3% of the mortgage. Let me double check. 0.03 multiplied by 188,000. 5640. That's correct. That's the points. Part D, find the monthly payment. I'm not going to use the formula, so calculator again. All right. Yeah, I hope at this point you should know how to use the calculator. I'm going to share again. Share my camera. Let's see what do we have. How many years this house? The loan, the mortgage. It's a 30-year mortgage. So monthly payment. So 12 times 30, 360. Annual interest rate, 10%, very high. I hope in reality we will not get that high. 10%. And highlight. Present value, the loan amount, how much you pay for the loan. And I'm going to go back the Part B. Loan amount can be found, the mortgage can be found in Part B. 188,000. 188,000. 3. Payment is what we're trying to figure out. So future value is 0, 12, 12. Solve for payment. Let me double check. 30-year loan, 10%. loan amount 188,000. Okay, that's correct. So every month you need to pay $1,649.84. Go back. Round to the nearest dollar as needed. Must read the information there. Dollar. So round to the nearest dollar as needed. So 1650. 1650. 1650. That's the monthly payment without taxes and insurance. Last part, find the total cost of the interest over 30 years. Okay, so you pay $16.50 every month over the 30 years. So multiply by 360. 360. That's how much money you spend on a house. Spend on a loan, actually. And then you're gonna use that amount to subtract the money you owe minus the money you borrow, 188,000. The difference, wow, the difference is a lot. The difference is 406,000. 406,000. 1, 2, 3. Okay. Only because the interest is so high. 10% is very high interest. Let me double check. You actually own only 188,000, but you pay 1,650 every year, every month, and multiply by 360. The 30-year loan. Yeah, that's about right. So that's this question. Question number 13. The price of a home is given. Banker requires 15% down payment. Buyer is offered 2 mortgage options. This is another big project. The first option is 15-year fixed at 8.5%. The second option is 30-year fixed at 8.5%. Only the difference is the time. Calculate the amount of interest paid for each option. Apologize for that. Something wrong with my computer. I always have to fix that. Let's go back to the question. Calculate the amount of interest paid for each option. How much does the buyer save in interest with the 15-year option? We don't have to use the formula. Determine the regular payment amount. Okay. Yeah, let's do it. I'm going to firstly get information for this question because I will not see it later. 2 options, right? One is 15-year, the other is 30-year. For both, the interest is the same, 8.5%. Price is $240,000, and you need to pay 15-year down payment. That means you have to borrow the 85%, the rest 85%, right? Okay. Ready to go to my calculator? Share camera. Turn it on, and let's go. Let's do the first option first, the 15-year. 12 times 15. Oh, do it again. 12 times 15. 12 times 15. 180. Interest rate is 8.5. 8.5. The loan amount is gonna be 240, 240, 2, 3, 4. Multiply by 85%, multiply by 0.85. All right? Yeah. Because you do not borrow the entire 100% of the price. You only need to borrow 85%. 85%. And future value is 0. Okay, and solve for the payment. Okay, let me double check. If we 240, 1, 2, 3 times 0.85, 204,000. That's correct. Okay, so that's you want to write it down. That's the payment for the 15-year option. Okay, I'm going to write it down on my scratch paper. My scratch paper. So this one is 200. What is it? 2006 or 8? 2008 87. 2008 87. Round it up to the nearest cents. And now let's do this 15-year option. Let's do the 30-year option, okay? Yeah, since we are looking at the calculator, I'm not going to share back again. And all we need to do here is to change the year. Instead of 15-year, we're going to do 30-year, okay? So 360 payments. Everything else going to remain the same, and we can go ahead to solve for the payment. And it's going to be 1568 point, what is that? 80, 58, 58, 58, okay. All right, so we're done with the calculator. Let's go back. I'm going to share the test. We have the true information found, right? The monthly payment for the 15-year option round to the nearest dollar. Okay, so what we had is enough. So 2009, round it up. And find the monthly payment for the 30-year option, rounded to the nearest dollar. And that's gonna be 1569. 1569. 1569. Double check, 1569, and that one is 2009. Okay, so that's the first two parts. Next part, calculate the total cost of interest for both mortgage options. How much does the buyer save in interest with the 15-year option? Well, let's do the calculation. For the 15-year option, let's see what's the interest. 15-year option. Every month you pay 2009 for how many months? For 180 months. 180 months. 12 times 15, yeah, 180. And that's the total money you pay, right? Yeah, we don't have to find the interest. That's enough for us to, because the money you owe is the same. So you contribute 361,620 in the case of 15-year loan. And in the case of 30-year loan, you pay 1569 every month for how many months? 30 year, 360 months. So you end up with pay 564,840. And the difference between those two amounts is going to be the difference of the interests. Okay? So we are going to use the bigger amount to minus the smaller amount, just wrote it down. 361,620. Oh, really? The difference is $203,220. 203,220. Hold on, let me see. If we minus this, yeah, that's the money you save. Yeah, of course, that's the money you save. 203,220. Use the answers from part 1 and part 2 and this answer. So you end up with paying 203,220. Not much money, not much more money. Calculate the cost of interest for both. How much does the buyer save in interest with the 15-year option? But normally in reality, if the time, the longevity of the loan is longer, the interest rate normally will go down. But our question, the interest rate remains the same. In reality, we'll have different. So that's the question. I hope I didn't do anything wrong here. 220. Okay, next. Number 14. Fill in the blank so that the resulting statement is true. Using a credit card is an example of an open-end installment loan because there's no schedule for paying a fixed amount each period. I guess you have to pay the minimum, but don't do that. Always pay in full and set up your auto pay. And those questions are a little easier. Okay, this is about credit card. Okay, so we need to determine the regular payment amount. Rounded to the nearest dollar, your credit card has a balance of $5,800 and an annual interest rate 18%. You decide to pay off the balance over 3 years if there are no further purchases charged to the card. Part A, the monthly payments are approximately how much? Do not run until the final answer, then run to the nearest dollar as needed. Yeah, let's see. This is also a loan problem. So the money you owe, the money you want to return, pay back, is 58,000. Okay, let me get the information. 58,000. That's the money you owe. You already borrowed, right? And annual interest rate 18%, 3 years, monthly, no further purchase charge to the card. How much must you pay by month? Okay, so we can treat this as installment. Even it's open-end. So let's go to share my calculator. Oh, turn it on. Okay, so you want to pay how many years you want to pay back? You want to pay the balance back within over 3 years, so monthly. So 12 times 3, 36. And annual interest rate, 18%, very high, 18%. Present value is the money you want to pay off over the 3 years, 58,000. Future value is 0, 12, 12, and okay, payment, double check, 3 years. 3 years, and the balance is 58,000. Annual interest rate 18%, 0, 12, 12. Okay, 209.68. Let me write it down. Yeah, let's go back. Monthly payments round to the nearest dollar. Okay, round to the nearest dollar. What is that? What is my answer? 210. 210. 210 would be the rounding. The total interest paid over 3 years. Okay. So we just treat it as an installment, even it's open-ended. Over 3 years. So you pay 210 every month for 3 years, so multiply by 36. And that's how much money you pay over 3 years. And how much money you owe? You owe 5,800. And the difference is your interest, 1760. 1760. 1760. Next. Okay, I assume those are not going to be using the calculator anymore, right? I hope so, because I'm going to get my mouse back. Yeah. So use the English and the metric equivalents to provide at the right. So we are going to convert 11 decimeter to inches. Okay, this is what we do. I'm going to mainly say it, okay? You get your calculator ready. So firstly, we want to convert decimeter to centimeter. We want to convert from decimeter to centimeter. That's something you need to remember. Decimeter is a bigger unit. So 11 decimeter is 110 centimeter. It doesn't give you, so what I'm trying to say is you need to memorize this formula. For test 2, you need to, let me get you the formula. Let's go to our guided notes. Downloads. 9.1. I emphasize that in the video. If you ever watch that, what do you need to memorize for the purpose of test 2? Is, where is it? The metric system conversion, and yeah, right here. Yeah, that's something I want you to memorize, because obviously the question doesn't provide, right? Okay, so from decimeter to centimeter, you go to the right one time. So your decimal is gonna go to the right one time. Okay, so 11 decimeter is gonna be 110 centimeter. From centimeter to inch, you are going to divide it by 2.54. Why? Because inch is a bigger unit, so the number in front of it is going to be smaller. And round it to the nearest hundred, so keep 2 decimal places. 43.31. 43.31. Yeah, I think you should watch my video for chapter 9 and grasp the method I taught, because the method taught by the textbook isn't a convenient method. It takes a lot of fractions, and I believe you do not like fractions. So round to the nearest hundreds as needed. So 43.31 inches. Okay, so that's that. Next. 290 inch to decameter. Yeah, DAM. So as you can see, it doesn't given. So we have to go from inch to centimeter. Let's do this. Let's go from inch to centimeter. Centimeter is a smaller unit, so the number in front of it is going to be bigger. So we're going to multiply 290 by 2.54. And the result is in centimeter. So how do we go from centimeters to DAM? Look at it here. Again, this is something you need to memorize, okay? From centimeter to DAM. So we have earlier, we have 736.6 centimeter. Now we go from centimeter to DAM. So 1, 2, 3. 3 times to the left. So we are going to move the decimal point to the left 3 times. 1, 2, 3. So 0.7. So divide by 1,000 basically. 0.7366. Round to 4 decimal places are needed. Round all intermediate values to 4 decimal places are needed. We didn't actually round anything, right? So the exact value is 0.7366. Next. So when you don't have the equation, conversion equation between the two units directly, you have to find a bridge. Our method is go from inch to centimeter. Okay, and then from centimeter to decameter, and use this diagram. You need to memorize. Again, you need to memorize the diagram for the test purpose. Please do so, because you only have 15 questions in the test. If you mess up 1 or 2 only because you don't remember the diagram, you are not going to have a good score. This one, a feet to meter. So the equation between feet and meter is not given. But we have the equation between feet and centimeters, right? Let's do centimeters first. 8 feet to centimeter. Centimeter is a smaller unit, so we are going to multiply by the factor, by the conversion factor. We're going to multiply 8 by 30.48, 30.48. And we got 243.84 centimeters. From centimeters to meter, we move the decimal point to the left twice, as you can see from this diagram. From centimeter to meter, 1, 2, right? To the left twice. So we're gonna move the decimal point to the left twice, 2.4384. Rounded to final answer to the nearest hundredth. So we have to round it to the nearest hundredth. So keep 2 decimal places. 44. Okay. Let me double check. From feet to centimeter, we have 30.48 multiplied by 8, and that is how many centimeters. And convert to meter, so 2 meters, 44, 2.44 meters. That's correct. From milliliter to cc, cubic centimeters, do we have the connection between the two things? Yeah, the first row in the table. Cubic centimeters and milliliters, they are the same size of unit. So we could just round to the nearest hundredths. We don't have to do any rounding. Millimeter to cc, cubic centimeters. Same thing, just enter 264. And we'll go back later to see if it's correct. Should be correct, because milliliter is the same with cubic centimeters. It's just one's for capacity, the other is for volume in metric system. Okay, next. Kiloliter to cubic decimeter. Let's see. Kiloliter. I'm going to okay, so I'm going to use the second row. Okay, the second row. 1 cubic decimeter is 1 liter. You see that? Very convenient, right? And how many liters in 21 kL? 1, 2, 3. The kilo is just 1,000, right? So 21 kiloliter is 21,000 liters. And 21,000 liters is the same with 21,000 cubic decimeters based on the second row. Let me double check. 21,000 kilo, 21,000 liter, and liter is the same as cubic decimeter. Okay. Next, let me see, double check my recording. I'm recording, I'm sharing, and I'm not muting. Okay. Every time I'm very nervous when I make the video, by the way. This one, milliliter to teaspoon. Let's see the information we have. Milliliter and teaspoon, TSP. Oh, the first one. Okay, the first one. As you can see, 1 teaspoon is around equal to 5 milliliters. So the conversion factor is 5, and the milliliter is a smaller unit because the number in front of it is bigger, right? So we are going to convert the 22 milliliters to teaspoon, and teaspoon is a bigger unit. So the number in front of it is going to be smaller. So we are going to use 22 to divide by 5. 22 divided by 5. 22 divided by 5. 4.4. 2 decimal places as needed. We don't really have that. 4.4. Let's put a 4.4 for now. And let me double check. 1 teaspoon is 5 milliliters. So 4.4 times 5 does give us 22 milliliters. Teaspoon is bigger. Teaspoon, TSP, is bigger compared with milliliters. And next, from pound to kg. Yeah, do you see the conversion equation, the last second? 1 pound is around equal to 0.45 kilograms. So kilogram is a bigger unit. And we want a number in front of smaller. So how do we make it smaller? Simply multiply 990 by 0.45. 390 multiplied by 0.45. You do the same thing in your calculator. And we have 175.5. 175.5. Rounded to the nearest hundredth. We don't really have. Let me keep that just like that. And then later we check, do we need to put a 175.50? And those experience should based on your practice in those 2 chapters. I guess I didn't practice enough. I don't remember the thing. So let's put that for now. 390 times 0.45. Next, pound to grams. We have pound to kilograms. So let's go from kilograms and then from kilograms to grams. So from pound to kilogram, we multiply by 0.45, right? Same with earlier. 81 times 0.45. And we have 36.45 kilograms. And from kilograms to grams, kilo means 1,000, right? And we are going to move the decimal point to the right 3 times. So 36.45. 0. That's how many grams. It's the same with 36.45 kilograms. That's correct. Kilograms per pound. So the conversion factor between kilograms and pounds is 0.45. Pound is a smaller unit. So the number in front of it is going to be bigger. In order to make the number bigger, this time we are going to divide 690 by 0.45. That's how do we make a bigger number. Round to 2 decimal places as needed. So 1533.33. All right? Yeah, pound is a smaller unit, so the number in front must be bigger. In order to do that, we must divide 690 by the factor 0.45. Again, watch my video for chapter 9 to grasp the method I'm using now. 25. What is this about? About tax, find the gross income, AGI, taxable income, based on the greater of standard and itemized deduction. A taxpayer earned wages, received 290 interest. So his gross income, we are going to add 56,500 with the interest he got 290. And that sum is his gross income, 56,790. 56,790. 56,500, 290. Okay, AGI, do we have any adjustment? Yes, he contributed 7,900 to a tax reform retirement plan. So we're going to subtract that from the gross income to have AGI to minus 7,900. 48890. 48890. We are dealing with numbers, so be very, very careful. Taxable income, well, we have to compare. That's the standard deduction, right? Standard deduction is $12,550. And his itemized deduction, he had itemized deductions totaling 6,000 only. So no, we're not going to subtract itemized deduction. We're going to use the standard deduction. Remove the standard deduction from AGI to have his taxable income. So minus 12,550. 12550 and 36,340. 36340. This is about FICA. Okay, so two categories. Actually, three categories. The middle one is the employer, but for a certain person, he only look at one of the two columns. So let's see if this guy is self-employed or not self-employed. The taxpayer is not self-employed, so we look at the first column and earned 120 grand gross income. So what's his FICA? I think I need to So now I'm not muting. I am sharing and I am recording. Sometimes it muted myself. It mute me for some reason. So I apologize for that. Let me repeat what happened just now. So since the gross income is less than 142,800, we only need to apply one FICA rate, which is 7.65%. All we need to do here is to use 7.65% to multiply by his gross income, and that is the tax amount. I said also earlier that we're going to keep this to see if the rounding is acceptable, because the instruction said round to the nearest cent. We don't really need to round anything, and I don't really want to write 9180.00. So let's try if that works. If not, we know what should we do during the test. And number 27 is also about FICA. Double check I'm not muted myself. Okay, awesome. Next question about FICA. So this guy is self-employed. Okay, we are going to look at the last column. He's self-employed, and he earns 149,000. Oops, we need two rates for that. Okay, we need two rates for that guy. What's his FICA tax? So let me get the information. And I'm going to demonstrate the expression in the OneNote. So his gross income is 149,000. Okay, so it's go beyond 142,800. So for the first $142,800 he make, he needs to pay this much. Okay, for the money exceeding that amount, so we use 149,000 to minus 142,800, and for that money, extra money, he pays 2.9%. Let's do the algebra. So I'm going to use my calculator. 15.3%, 0.153. multiplied by 142,800, and that product is 21848.4. All right, and in the parentheses we have 149,000 minus 142,800, and the extra money he gonna pay 0.029, 2.9% interest on that, and that money is 179.8. As a self-employed, he has to pay both himself and as employer of himself. So add that on top of 21848.4, and we have 22028.2. Okay. So I should have everything correct. 149,000 minus 142,800. Be very careful with the numbers. 2.9%. 0.153 multiplied by 142,800. It never hurt you if you double check your result. 21848.4. Okay. So the answer is gonna be 22028.2. Let's see how do we round it. Round the nearest cent, okay, as needed. So we are going to have 22028, 22028.2. Again, let's see if it works without a enter 0.20. Right? Yeah, 22028.2. Next, this is about simple interest. All right, very good. Simple interest formula: I equals P times R times T. T must be in years. Okay, so do not multiply by 9. So we are going to multiply 2,000 by 8.5%, as decimal is 0.085, and then multiply by 9 months is how many years? 9/12. So I'm going to multiply by 9 divided by 12. That's how many years we have. That actually is 3/4 of a year, right? Or 0.75. Yeah, let me double check. 2,000 times R, 0.085, 0.085 times 3/4. And the interest, round to the nearest cent as needed. 1 to 7.5. 1 to 7.5. Next. This is about simple interest as well. Part A, interest. So P times R times T, right? P is 2,000. The loan amount is 2,000. 2,000 multiplied by annual interest rate, 0.1225. That's very high. 0.1225. And then multiplied by times in year. 3 months is a quarter of a year. So multiplied by 0.25. We have 61. That's little money for 3 months. Round to the nearest cent, 61.25. Let me double check. 2,000 times 0.1225 and then times 3 months over 12 months is 1/4, 0.25. Yeah, that's correct. And the future value of the loan. Future value of the loan, you just need to add the interest on top of the money you owe. You owe 2,000, so you're gonna pay back both principal and the interest in 3 months. Round to the nearest cent. So 220, 61.25. Number 30. The principal represents an amount of money deposited in a savings account, subject to compound interest at a given rate. It's about compound interests. Answer part A and B. Find how much money there will be in the account after the given number of years. The amount of money in the account after 4 years. Okay, so I don't want to go back my calculator, like share the camera. So we are going to use the formula, okay? Which formula? For the future value, you're going to use the first formula, all right? Principal, original principal to multiply a certain power of the compounding factor. You should know what is a compounding factor if you watch my video or study my table note. So this is what we're going to do. We're going to multiply the principal 9,000 by a parentheses. In the parentheses, we have 1 plus. How is going to be monthly? So plus monthly interest rate, which is 0.045, 4.5% divided by 12. Close the monthly interest rate, close the compounding factor, and raise to the power of 12 times a year for 4 years, 48. I got nearest hundred, so nearest cent, 10771.33. Okay, so let me quickly use the app to double check. Monthly for 4 years, so 48. Annual interest rate 4.5. Present value 9,000. So payment is 0. Future value 10771.33. Correct. And the interest earned. So let's see, how do we find the interest earned? You have that much money. Let's see how much you have been Of course, this is pretty straightforward. Simply use A to minus P, okay? Use the money you got, 10771.33. It says use the answer from part A. You would always have to use the answer part A. So find the interest earned. Use that to minus the original principal, 9,000. And the difference is the interest. So it's 1,771.33 hundredths, so cent. All right, I hope I can get it done within the time frame. How much money should be deposited today in order to get 10 grand in 3 years? So this is about the compound interest as well. If you use a formula, the second formula you're going to do, that's the formula you're going to do, okay? So I'm going to use both methods, but I'm not going to demonstrate on the camera. You can just listen to me. So if we use the calculator, we are going to use 10 grand, 2, 3, 4, to divide it by a parenthesis. In the parenthesis, we have 1 plus the monthly interest rate, which is 0.045 divided by 12. Close the compounding factor and raise the compounding factor for how many years? 3 years. So 12 times 3 is 36. And the answer I got nearest cent is 8739.37. And I'm going to double check this answer using the app. And even you use both methods, it won't take too much time. So in this case, 3 years, so 36 cents is monthly. Annual interest rate 4.5. Present value is what we want to solve for. Future value, you want a 10 grand. 1, 2, 3, 4. And let's go back to solve for the present value. I got 8739.37, same thing. Earlier, we had a similar problem, right? So I already demonstrated on my calculator. 32, question number 32. Now, an account has a rate 2.9%, find the effective annual yield. Okay, this we need to use the formula. The last formula, okay, is the annual yield. Is the annual yield formula. And R is 2.9%, 0.029. N is 12 because it's monthly. Just plugging in. Okay, so let's use the formula to plugging in. And we have, I'm going to start a parenthesis, 1 plus, start another parenthesis. In the second parenthesis, we're going to have the monthly interest rate, 0.029. 0.029 divided by 12. Close the monthly interest rate. Close the compounding factor. Raise to the power 12. And then minus 1 from it. And I got a decimal. And round to the nearest hundreds as needed. So I'm going to enter 2.94. 2.94. Be aware, the right answer, your effective rate, the right answer would be not far away from the nominal rate annual interest. Okay, so this seems right. Let me double check my formula. Yeah, just plugging in. That's correct. Get this closed. Next. This is the last question, right? Yay, we're almost done. So you would like to have 4,000 in 5 years for a special vacation following graduation by making deposits at the end of every 6 months in an annuity. So this is about annuity. We haven't been doing annuity a lot, right? So I'm going to use my calculator. I just say it, and you do the same thing on your calculator, all right? So let's go to the app. This is about annuity. I'm not going to use the formula. So you need to, so it's compounded semi-annually. Semi-annually. When do you want to have, how much should you deposit at the end of every 6 months? When do you want to have the vacation? In 5 years. Okay. Semi-annually, so twice a year for 5 years, so 10. Your big N is 10. Your annual interest rate, 6%. Compounded semi-annually. And your present value, remember, annuity always have 0 as present value. Payment is we're going to solve for. Future value, you want to have how much money in the future? You want to have 4,000, right? 4,000. That's what you want, your financial goal. So semi-annually, so P per Y, C per Y, both are 2. And now let's go back to solve for the semi-annual payment. Alpha enter. I got, we need to round up. You see that? Yeah, read this information, please. Round up to the nearest dollar. So I have 349. Before move on, let me double check. It is semi-annual for 5 years. So 10. Annual interest rate is 6. And present value is 0. Future value is 4,000. P per Y, C per Y is 2. So solve for payment, 349. Round it up. How much money from your deposits? You deposit 349 every 6 months, right? For how many semi-annual period? 5 years, so times 10. So that much money is from your deposit. 3490. And how much money from your interest? The rest is from your interest, right? The difference, 510. So minus 4,000. 510. That's from your interest. Round to the nearest dollar is needed. Okay, let's submit. It's a very long test. How much did I get? Oh, I got 100%. Perfect. So do not rush, okay? Yeah, so from the practice, you would see if you got a 19, for example, and the question says round to the nearest cents, you don't really have to write 19.00. We tried and we got it right. All right, guys, that's everything for the review of test 2. Please be ready, and test 2 is very important. Email me if you have any questions. I'll see you in the next video. Good luck.